Welcome friends in Science Lecture 2, Lesson 10, Gravitation. Fine, in today's lecture we are going to learn about free fall. Now, what is free fall is that an object falls towards the earth under the influence of gravitational force alone. That is it is in free fall. Fine, the objects are called as in free fall. Now, the gravitational force is the force that pulls, right? This is an only certain forces has the capacity to pull and repel also, but gravitational force has the capacity to pull towards itself, as we have learned in the last lecture. So earth is a very big object and it has capacity to pull the other objects towards itself on earth surface towards the earth surface. So this kind of force is called as an gravitational force by the earth towards the other objects. Now there is no change in the direction of motion, like we have seen that when a ball is thrown from the top of the building, it falls in the free fall towards the ground. Like if a ball is been dropped, not thrown, basically it is been dropped from the top of the building, it falls due to the gravitational force, gravitational pull towards itself, and there is no change in the direction. It directly goes towards the earth without any change in the direction. But yes, there is a change in the magnitude of velocity. Now, what is a change in the magnitude of velocity? Is the velocity is changing with respect to its certain value as constant, and this attraction is there toward this change in velocity is due to the attraction by the earth. Now, any change in velocity is acceleration, and due to the earth's gravitation is called as an gravitational acceleration. So we can say that this change and this acceleration which is being produced by the change in velocity is due to gravity, that is earth's gravitation, is called as an gravitational acceleration. This gravitational acceleration is denoted by small g, and its units is or r is meter per second square. Now, by the second law of motion and gravitational force, F is equals to mg, and F is equals to capital G m into m upon d square, that is the product of the masses upon the square of the distance between them. Now, comparing these two equations of forces, mg is equals to gm into m upon d square. Fine. So cancelling m and m on both the sides, we get g is equals to capital G capital M upon d square, or g is equals to capital G m upon r square. Fine. Here g is gravitational acceleration, m is the mass of the earth, r is the radius of the earth, and capital G is the gravitational constant. Fine. So these three values, we keeping these three values in this particular equation, where these three values are fixed, where m is the mass of the earth is 6 into 10 raised to 24 kg, radius of the earth is 6.4 into 10 raised to 6 meters, and gravitational constant is 6.7 into 10 raised to minus 11 Newton meter square per kg square. Right. So putting all these three values in this particular equation, we get g is equals to capital G m upon r square, keeping capital G as 6.7 into 10 raised to minus 11, 6 into 10 raised to 24 as mass of the earth, and r square as 6.4 into 10 raised to 6 whole square. Now, putting these products and finding up the values, ultimately we get an answer as 9.8 meter per second square. This is acceleration due to gravity, and this value is fixed, right? So g value is fixed, and we count this value as 9.8 meter per second square. Now, g is increasing at pole than equator because radius decreases at pole than equator. That means approximately 18 to 25 kilometers, the radius of the earth is less at pole and more at equator. So in the inverse of it, we say that the gravitational force, that is gravitational acceleration, is more at pole and less at equator. Fine. So we are living on equator, so our gravitational acceleration is least compared to that of the at the pole. We will feel more pull towards the earth. Fine. Now moving towards the next part of it are sums. Before that, we'll take three equations of motions of free fall. We know the equations of motion. In the same equation of motions, the three equations, as we know, and putting the values as initial, because as we are throwing something from top to bottom, we understand that initial velocity will be 0. Acceleration will be due to gravitational acceleration, and distance is because of its height. So distance we are going to take as an height as h, a we are going to take as g, and u we are going to take as 0. Putting these values in the original equations, we get our original equation was v is equals to u plus at. So we get here as v is equals to gt, because u will turn as 0 and a is going to turn as g. In the same way, v square is equals to 2ag. Same equation is v square is equals to u square plus 2as. So putting these equations here, u is turning as 0 and a as g and s as h, we get this equation particular v square is equals to 2 gh, or v is equals to root of 2gh. This is only for free fall. Please understand this. This is only for free fall, not for any kind of suppose if a ball is thrown from below to top, these equations are not going to be worked. Only the ball when it is thrown without any force in the free fall from the top of the building towards the ground, this equation can be taken. So such free falls can be taken for this equation should be taken. Here we know that s is equals to ut plus half at square. You know this equation of motion, three of them. So the third one comes out to be, instead of s, h, u is 0. So this whole equation turns out to be 0, and half at turns out to be half gt square. Right? Taking into this example 10.2, we get here that taking the values here in equation 10.2 here, example, that is a car is taken here. In the example, the time is taken as 0.5, g as 10, and initial acceleration, initial velocity as 0. We get speed we need to find out in the first case. So the speed will be equals to, taken in the free fall, that a car falls from the edge from the top of the building towards the ground. So taking the edge of the building, so when it falls, this is a free fall, so v is equals to gt. We can take this equation here because of the free fall. So g is taken as 10 and time as 0.5. So 10 upon 5 upon 10, cancelling it out, we get 5 as an answer. Same with, and secondly we have to find an average speed. So average is initial plus final velocity divided by 2. So the final was v and initial was 0. So this 5 by 2 comes out to be 2.5. Right? In the same way, the third, we have to find the height from which the car has fallen. So h is equals to half gt square. H is equals to, here h is equals to half gt square in case of free fall. So h is equals to half gt square in the free fall. Half multiplied by g as 10 and t as 0.5 square. We get an answer here as 0.5 square, 10 into, so 1 by 2, 10, 5 upon 10 and 5 upon 10. So here we get, cancelling this, all of them 110 got cancelled here, 5 ones and 5 twos are. So 2 and 2 is left out and 5 is left out. So it turns out to be 5 by 4 is equals to 1.25. This is how we can calculate this particular sum. In the next form, furthermore, taking this is a basically sum here. A car falls off the edge and drops to the ground in 0.5 seconds. Let g be 10 and we need to find this. So all the three things, first we found the speed, secondly we found an average speed, and third height. So we found the height here. So all the three things are measured here in this particular sum. The second is 10.3 as in sum. 10.3, an object is thrown vertically upwards and rise to the height. This is not a free fall, this is thrown object from top to bottom, sorry, from bottom to top that is ball is thrown upwards vertically and it rises to 10 meters. Calculate the velocity. This is the calculate, we have to calculate the velocity with which the object was thrown upwards. That means the initial velocity we need to calculate, and time taken by an object to reach the highest point. That means initial velocity and time we have to find it out. So taking these things into consideration, height is given, that is 10. Final velocity after reaching at the top turns out to be 0. Initial we have to calculate, and gravitational acceleration is not given, so compulsory we have to take as constant value as 9.8 meter per second square. So we know the equation of motion as v square is equals to u square plus 2as. The final velocity is 0. So keeping finding for initial velocity 2 multiplied by minus 9.8, because it is inverse of acceleration. Acceleration is decreasing going towards the top, so it is in minus. This is deceleration, no? The multiply by 10 as an height. So what we get, u square comes on this side, turns out to be minus, and minus sign also here. So minus minus gets cancelled. So what we get is 2 multiplied by 9.8 comes out to be 19.6 multiplied by 10 is 196. So u is equals to root of 196 comes out to be 14. That means the object thrown upwards, initial velocity was 14 meter per second. The next is we have to find the time. So v is equals to u plus 80. Final velocity is 0. Initial velocity we have found as 14, and minus, because as we have known that the acceleration is decreasing, so deceleration. So minus 9.8 into 10. Keeping these values here, so 9.8 t is equals to 14. This we have taking it on this side, so it is 14. So 14 divided by 9.8. So t comes out to be 14 multiplied by divided by 9.8. So 10 we have taken up and 98 here. So 14 7 2s are and 7 14s are, and 2 1s are and 7s are. That means it comes out to be 10 by 7. Division, we get an answer of t as 1.43 seconds. Fine. So we have solved these two sums. I hope so you have understood, and kindly please you also solve these sums from the textbook itself, also taking the help of it, and I'll send you the photographs for this also. Fine. Thank you for this particular lecture.